is Kate Hernandez. I'm going to be explaining the inquiry labs. So the first lab is the iodine clock lab, which is this one. And what we had to do is we had trials for the 4 following datas, and it just asked us to write a chemical interaction. So the first one was that we had to check if the information investigated of the beakers were colorless. So we just made it start. So what we try to do is get the enzymes and try to catalyze them and see if that the temperature is the one that affected it, so it can change the color. So we did 1, 2, I'm pretty sure we did 3. No, we just did 2. And then after we answered all the questions relating to the certain amount of investigation needed for one certain ion, we also did a graph explaining the trials, which is trial 1 and 2. And then I graphed every single point that was on there. And what I did was I put the temperature on the Y value and the time on the X value. And I just did it by 5 all the way to 45. And this one by 60 because it was a little longer. So I extended the graph. And it was a difference because in temperatures it did affect it. So every temperature made the catalyst either change colors faster or a little slower. All right. So explaining lab 2. Lab 2 for the inquiry labs was chemical kinetics, and this one was just to see also if the color changed. And this one also. So it just made us check. Water was H2O, H2O2 was the moles, HCl, and then the Ki, and then the temperature. So we could either set it to 5, 15, 25, 35, or 45. And so they made us do 8 trials in every single data table. And it was for the reaction to see if the chemical interactions took place in the solution, if it was colorless, or the product turned into a certain reaction. Then, after doing the certain amount, because it also made us say, well, it made us do that it had to equal to 100 specifically. So it did give us the first one, which was 60. And so I just did 60, 50, 40 and throughout, but I made it sure that it equaled to 100. And then just the time and temperature, which is 25 degrees Celsius, and in seconds how long it took. And then the other one was the second trial, and they made us do it with ourselves. So what we took from our last data table, we would turn it into here and check how much time in seconds it was with the different amount of chemical reactions. For the last and third data collection for inquiry 2 of the lab, we basically took the main 5 degree points that it wanted us, and we just changed the rate and temperature and saw how fast it changed in seconds. So in 5 degrees Celsius it was 25 seconds, in 15 it was 23, and then every time the temperature rose, less seconds would take for the actual color to change. And we did the same thing here. We drew a graph. All right. Lab 3 inquiry. So the lab 3 was the acid-base buffers, and this one was to see if the buffers of the actual chemical equation reflected either if the a certain chemical solution was either acidic, basic, or neutral. And I know between 1 and 14 to make sure if it's acidic or basic, or 7 makes it neutral. And the solutions were either I know in the website when we did the buffers, the actual thing that, so we could actually input the information, was either acidic and then basic. And I know basic solutions were almost like salt, and that would either make the pH go up or down, making it either acidic or basic. And mostly they were all acidic, 1 or 2 were basic, and just 1 came out neutral. The data analysis interpretation. So we considered a stronger base solution, and then the chemical equation that reflects the acidic, and then I wrote down the actual chemical equations, and then to make sure that they were acidic or not. And then this one as well, we had so we had two tables. The first one is that they gave us our chemical equation, and we had to make sure the pH balance and the concentration of the actual acidic being placed in the beaker to make the chemical pH go up or down, and then the concentration of the salt that's being used. We also answered the questions that they asked, and we also compare the certain chemical equations that I want us to, like HC2, H3O, H3O2, and then how much time it took for the actual acidic or buffer to change the color of the solution. And then he gave us another data table right here, and it had some inputted as for the pH after adding the 1 times 3 moles of acidic or basic, and then make sure that the pH would either go up or down. And I believe that if it was around 2.7 to 2.2, it would either stay around the 4.8 or 4.2 and then go down to at least 3.9, which was probably the lowest pH balance. And then later on, we analyzed and interpreted the data and make sure which is if we compare the actual things. Then we list all the buffers that we used to actually consider it to make it an acid or basic or neutral concentration. Okay, next lab, which is our botanic cells, which is lab 4, and this is also an inquiry lab. This lab was, so what it did was, in the website, it had a solution where a beaker and another beaker were were connected by this voltage I would say simulation, and had a specific metal in each one. In this metal, it would either determine if it would go into the left beaker or all to the right beaker, and then depending on how strong the ions were for this one, then it would either not the ions, the voltage, it would either go to the left or to the right. But I think it mostly went to the left, and it was hardly like one to the right. And yeah, because in the data table it made us pick the certain cells and then the metals and then the chemical solutions that either turned them to the left to the right. And then mostly all were from right to left for the electrodes of the electrons to turn, and the voltage would either if it went from left to right, it was a negative number, and then if it was just right to left, it was always be a positive number. We also wrote down the 6 combinations of the tables needed for the chemical equations to actually know which direction that it needed in volts and then the electrodes. And then so we also have a chemical reaction, and then we reacted either the ones that they gave us to see if it was like Cu or Zn, or if it reacts with it or if it doesn't. Yeah, that was this one. So the next and last lab for the inquiry labs was the metal and metal ion reactions, which is this one. And this one, it was 4 different types of solutions of ions. So they gave us, and they wanted us to write down the color, and in our own ones describe why H2O molecules weren't displayed in the magnifying glass. So in the simulation, they gave us these 4 beakers. They gave us a magnifying glass it was like a micromonic solution where they would make us look at every single one and actually get the solutions and actually write down what they were. And so that's what we continue doing with another 4 different types. And I guess this lab kind of repeated itself, but just with 4 different types of solution each time. But then after we write down the chemical formulas and record the number of species in each beaker, we will list at least 3 characteristics if they were the same ions or different amount of ions. And also we would either make a reaction, because in the simulation it made us check if it had like a color change, or if no reaction, or like the solids turn into liquids, or different types like that. So we continued on with the analysis. And basically, like I said, after writing the chemical equations for each and every single one to actually complete and to make sure that we knew, the order was based on the relativity of the strips, so the metal strips that were actually placed into the beakers, to make sure that the submicronic cells were viewed instead of the H2O cells. And then also the most reactive ones were placed on this side, and then the least reactive and the metal ions and the actual metal. So the metal used were, in this case, Ag, Cu, Zn, and Mg. And then if they were either positive or negative, and then if they were positive, that was mostly reactive. And then we also broke down the chemical equations for the metal ions that were used, and then the metal ions from the columns also. And basically it just was a repeat of the same thing, so we would continue doing it and make sure that it was a color change as well, or no reactions with a certain amount of chemical equations that they made us use. And also rewriting if there was a strong or low equation on it. And then yeah, we continued on doing it, and then basically later on we had they gave us a certain amount of equations and make sure that we could rewrite them all. And then yeah, that was the metal ions lab, and this is the final inquiry lab. And that's it. Thank you.